All right, friends and neighbors, time now for DNS resolvers and queries and name servers, the protocol. This will be part 3 of that 3-part series. So the first thing that I wanted to look at is a basic query and answer exchange, right? So we know that DNS is query and answer, and the protocol is designed to get the exact format of the answer that you need back. And so what happens is when we do a query, the query, as we know, is going to be of a class of a particular type, IN, right? And then the record type is going to be A or PTR or something like that. And every one of those has a different, well, or can have a slightly different structure. So here are two messages that go together. Here we've got this client, 15.11, goes out to the name server, and the name server comes back with an answer. Well, the basic format of all protocol messages is going to be this. We have a transaction ID right here. We have the flags field that tell us what's going on, and then we have the number of questions and answers. Now, there's a little hint right here that we have answer resource records and authoritative resource records. We'll see what that means here in a second. And then here is the query, iana.org. I need the address that goes along with this particular query. The answer that comes back is pretty straightforward. There was one question, and there are two resource records that come back. Now, if we look at the header field here, we can see a couple of things. The client initially requested recursion, and that recursion is available if needed. But this is not an authoritative answer that comes back, which is why this record says, I'm an answer, but I'm not authoritative. Here's the original query, right? Type A, class IN. Iana.org, not a real thing. It's a C name for something else, this thing right here. And as we saw from, if you watched the previous video, you know that this will result in another query, but that's not what we're after right now. And the answer comes back with the proper IP address. By the way, that 192 right there, not a private address. 192.168 would be private. So let's take a look at the header portion first. The first thing that we see is this transaction. Now what we'll see is that queries and answers that go together will have the same transaction ID. And then, of course, we have some records here, but this portion over here, the header that we're looking for, is the general header, right? So the general the components that we're looking at is this part of the header, the query, and then the answers that come back if there's an authoritative name server out there, and then any additional information. This particular message doesn't have an authoritative name server or any additional information. So let's take the first part of the header section and the flags. So that's this part right up here. There's our ID, and this is an identifier for the message and the answer that's supposed to go along with it. Now the rest of these are all flags that indicate what's going on with this particular message. Is it a query or is it a response? Is it an answer? The opcode, standard query, inverse query, server status, things like that, these are the ones that we're going to use most of the time. And then, is this an authoritative answer? Did I ask for a recursion? And if it's an answer, I might have whether or not recursion is available. So these are pretty straightforward single flag fields. We saw some of these here when we expanded this field, right? Now it makes a difference because we don't know what kind of query we're asking, and we don't know what the server is going to give us back. But this is just the information that tells us what's up with this particular message. Now the response code, or the R code right here, this is a 4-bit field, right, that tells us, you know, what's sort of going on. Now if you have a problem with, that's really where we need this. But 0, no error, okay, thanks. But I got my answer, and so I'm happy. So this is really, if there's a problem with the message, this is the code that we're going to actually look at. Now the rest of the part of the header is pretty straightforward. These are just counts, and they are unsigned integers, meaning that there's no negative values here, right? So the numbers, the binary values or the hexadecimal values are pretty straightforward. We get a query count, answer count, and then here is the authority, right? Whether or not there are authoritative answers, and then is there anything else that we need to know. So this part of the header is actually pretty easy. It's just a set of counters. Now on the top right of this particular slide, we've got the original query that goes out, and I just arranged it this way for space on the slide so you could see my smiling face. But the first thing I want to point out is the transaction ID. This one is 3205, And here's the answer that comes back, also 3205. Here's the question, right? And here is our flags field. Now it's pretty straightforward. Standard query. I'm asking for recursion if you can do it for me. And I've got one question, and here is the question that I'm asking. So the response comes back, or the answer comes back from the server, and the server tells me, this goes with this particular message, and I'm non-authoritative for this answer. You asked for recursion. I have recursion available if you need it. No error codes. And then here was your original query. By the way, you asked one question. I've got 2 resource records associated with this. One is the fact that this is a CNAME, and then one is the stored answer that I have. Now you might make a lookup for this particular address or this particular host name, but there you have it. And so we actually see that a client will a lot of times do that. So it's a pretty straightforward read through as far as this goes. The really fun part about these messages is how the servers are interacting. Now, there's a lot of writing on this screen, but really what it comes down to is this right here. This is what we're talking about, right? So we have a class associated with every query and every answer. We have a type for every query and every answer. And then here is the host name that I was looking up, and then of course we got the address that's part of the answer. So all of this stuff out of the RFC is really trying to tell us that. Here is the question that we're asking, the type in the class. We know that the type will almost always be IN, or the class will almost be IN, and the type will be whatever you're asking for. So that's all that this is trying to say, right? The class, the only other one that we talked about would be chaos, but this is going to be what you see most of the time. And then the question will be one of those 16 different possible record types. And here's an example. Now the answer is exactly the same thing with one addition that we're going to make, right? So class is the same, IN. Type, whatever you were trying to get the answer for, I'm going to give you back that type. And then the domain name to which the record. So all of that stuff is same. This right here, the time to live, that's a little bit different, right? That's a little bit different. That is going to be how long you ought to hang on to this information. Guess where that comes from? The server. So every answer that you get comes with a time to live, meaning hang on to this answer for this amount of time, and after that you probably ought to get rid of it. Now we can see there's a couple of other details down here. How big is the information, or how big is the field for the information, and then here's the actual information that you ask for. Here's the actual answer to your question. Now resource records have different types associated with them, as we know, right? So we got name servers, start of authority, CNAMEs, pointers, A records, there's a whole bunch of them. Now each one of these has its own format. So an address record looks different than a CNAME record, which looks different than a pointer record. And so that means that when you type something in a query or a message, it has a different format. And so each type sort of indicates what the rest of the set of fields are going to look like. So, and these are just 2 examples. This one is the CNAME, pretty straightforward. The hinfo type has a little more detail about it. We don't actually see those queries, those type queries very often. And this is just an example. So this whole thing, right, is what this was referring to. Okay, so when we look at this one, is a type. It's got the class in, the type is CNAME. And so the rest of this structure right here is specified by the RFC, what that actually looks like, how much space you can allocate to it. And there's our time to live. This is how long you ought to hang on to this information before asking the question again. Now this stuff right here, because it's an answer, this is actually the R data that we would be given in this record. So you have the resource record, and in the resource record you have the resource record type, the resource record class, and the resource record data. Well, that does it for DNS. That is a lot of videos that we've done on this topic. I think it's time to move on to something else. We are going to go through a couple more examples before I close out this video, but I do want to make a note on DNSSEC. I can spend a lot of time on DNSSEC, but I'm not going to, because there's a terrific video series out there. If you look on YouTube for the Internet Systems Consortium series, they have a 10-part series on DNSSEC, so I encourage you to take a look at that. But right now, let's take an example of our packet traffic again. So let's take a look at these with a little more attention to detail. So this very first query, we can see that we've got a transaction ID of 9930. The answer is right here, also 9930. Okay, so that's our first field. Second up, we've got our flags, recursion desired, opcode standard query. Okay, cool, Z reserved, I can't do anything with that. And non-authenticated data, unacceptable. Well, that if I set that, I would want to authenticate. I've got one question in my counts. Here is the query type that I'm making, type A, class IN. Here is the R data that I'm after, or the data for here that I want the answer. Okay, so now our answer comes back, and we can see we already did the transaction ID. This message is a response. There's our type. Standard query was the original thing. I am not the authoritative server. And then you ask for recursion. I have recursion if I need it, but I have some cached data. There was one question. Here's my resource records. And here was your original query. We'll close that, and we'll take a look at the answers. Now each answer, this one is a CNAME. So the structure here is different than the structure here, or it can be depending on the type. Here's our time to live that's different. Here's the data length that's a little bit different. And then here's another time to live. We can see that there's two different time to lives. Why? Because one is an actual answer to the question that you had. Now, it also depends on what the server has for these time to lives, right? We don't just put the same time to live for everything. And then here is the original, here's the answer to the original question. So we had to get through a couple of queries to get, or a couple of answers to get there. Now what's interesting is that we see this one as a CNAME, right? This comes back and says, by the way, this is a CNAME answer for this guy. So the client turns right around and says, oh, well, maybe I ought to ask that. So now we're looking for this guy to sort of verify the information. Now this one is 69 dB, so it's a separate query. So 69 dB, here comes the answer. Here's what you originally asked for. And here is the answer that comes back. Okay, so the time to live on this one, a little bit longer, by the way. Still not an authoritative answer. Now I could get an authoritative answer if I wanted to, if I changed my server to one that was closer to maybe the domain of the destination. Now in some of the captures we've done, we see these pop up too. And since we've got one here, I thought I would mention what it is, right? So when you see AAAA, that has nothing to do with the address records that we've been dealing with. This is an IP version 6 and whether or not there's an answer out there. And we can see that the structure is quite a bit different. There we go. So that is an IP version 6 address. So that's what we're seeing there. And I think that'll about do it. Well, there we have it. Thanks for watching. Thanks for listening. Like and subscribe if I helped. And may those queries always find their answers.